Hello, we're going to go through the review for the test 9. For the first problem, it wants to know what the third term of the sequence is. So the n is our term number, so we're going to plug in 3 for our n. Now this left-hand side, the a to 3 just means the third term is, so that is what we're trying to solve for. So then we're going to plug in the right-hand side, how it is, into the calculator. We get 243. So we would have the third term is 243. For number 2, they want to know the 30th term, so we're going to plug in 30 for all of our n's. And we get negative 108,030 for our final answer. Now the next two problems are wanting the recursive formula for each sequence. The recursive, if you can remember, is relating it to the previous term. So we're looking for the pattern this way. Notice that they are adding 4 each time. So we're going to put a to the n equals a to the n minus 1 plus 4. This a to the n minus 1 just means previous term, and we're adding 4 to it. This next one, notice the pattern is dividing by 3 each time. So since it's dividing by 3 each time, we can put a to the n equals the previous term divided by 3. We could write our answer like that. We could put 1/3 times our a to the n minus 1 and write it like this. So those are some different options that you have. The next one is the explicit formula. So explicit, you're relating it to the previous term. So for explicit, I would write off to the side a t-chart. So you can relate it left and right. Alrighty, so we're looking for the pattern left or right. Notice how the top is just a constant, just stays 1. So I would start off with just putting 1 on top and then look for the pattern in the denominator. So 1 to 9, 2 to 10, 3 to 11, 4 to 12. It's adding 8 each time. So the n plus 8 all goes down in the denominator. Another way that I could see this, notice in the denominators it goes from 9 to 10 to 11 to 12, so it's adding 1 each time. So then if it's adding or subtracting by the same number, think of it as my slope. So my slope would be 1. So then I would have 1 n, and then from there, if I plug in any of these n numbers, see what I need to add or subtract as my y-intercept. So if I plug in this first one, 1 times 1 is 1. It's supposed to equal 9, so I have to add 8 to it, and then it will work. Alrighty, and then from here they want us to find the 25th term. So then we're going to, just like 1 and 2, plug in 25 for our n and see what the 25th term is. We get 1 over 33. And you can put it as a fraction or a decimal, either is fine. So 1 over 33, or you can do the 0.03 as a decimal. Alrighty, for number 6, again, we want to make our t-chart. Okay, and for this one, I notice again, even though I'm looking for the pattern left and right, that up and down they're adding by 4 each time. So I'm going to use that to my advantage, that my slope is going to be 4. So if I plug in 1 now, 4 times 1 is 4, it's supposed to equal 7, so I add 3 to it. And then it should work every single time. So that would be my equation. Now I want to find the 25th term. So then I plug in 25 for my n, and I get 103. The next part is determine whether the sequence is arithmetic. If so, find the common difference. So they want to know, are we adding or subtracting by the same number each time? So from here to here, we're adding 7, we're adding 7, we're adding 7. So we are adding 7 each time, so we would say yes. And then the common difference is positive 7. If it's not adding or subtracting by the same number, then it's not arithmetic. Alrighty, for 8 and 9, they want us to find the given term in the sequence. So for the first one, they are subtracting 9 each time. So since they're adding or subtracting by the same number each time, then it is arithmetic. So on our formula, we're going to go to arithmetic sequence, and we want to use that first formula. Okay. So we have a to the n equals a to the 1 plus n minus 1 times our d. Okay, so the 17th term is what we're trying to solve for. So we're plugging that in for our n's. Then this a to the 17 just means the 17 term is, we don't know, so that's our missing variable. Our a to the 1 is what our first term is, so that's 64. 17 minus 1 is 16. And then our common difference, what are we adding or subtracting by? We're subtracting 9 each time, so we're going to multiply by negative 9. So then we're going to plug that into our calculator. We get negative 80. So the 17th term would be negative 80. Alrighty, for number 9, they're adding 7 each time. So since they're adding 7 each time, again, it is arithmetic, so we're going to use that same formula. And we're going to plug in 7 for our n's. Okay, then we're going to go back through and see what else we know. So our a to the 7 is what is the 7th term? We don't know that. Our a to the 1, what is our first term? And then our common difference is we're adding 7 each time, so we're going to put a positive 7 there. And we're going to type this into our calculator. And we end up with, oh goodness, I plugged in the wrong number right here. For our n, instead of finding the 7th term, we want to find the 32nd term. So let me get that switched. We need to make a 32 here and a 32 here. So then we can find what the 32nd term is. I don't know how I got the 7th term. And so 32 minus 1, this should be a 31 here. Okay. So then if we go now and simplify this, we have 6.4 plus 31 times our 7. And we end up with 223.4. And that sounds like a lot more reasonable for our 32nd term. Okay, so again, should be 6.4 plus 31 times our 7. Alrighty, the next one, it wants to find the missing middle term of the arithmetic sequence. So we're going to go on our formula sheet to the arithmetic mean formula, which we can use whenever it's an arithmetic sequence and there's one missing term. So we're going to add the two numbers, divide by 2. And it doesn't matter which one is your x and which one is your y, you just add the two numbers, divide by 2. So we end up with 4 divided by 2, which is 2. So our missing middle number is 2. Now a way to check your work to see if your common difference is the same. So negative 14 to 2 is adding 16. From 2 to 18, they're adding 16. So we know we have the missing middle number. For the next part, it says determine whether the sequence is geometric. If so, find the common ratio. So if it's geometric, it's multiplying or dividing by the same number. So if it's not multiplying or dividing by the same number, then we know it's not geometric. So for this first one, Notice how they are adding 7 each time. So since they're adding 7 each time, then we're going to just put no, it is not geometric. The next one is dividing by 3 each time. So we would say it is yes, it is geometric. And then your common ratio always has to be what you are multiplying by. So if we're dividing by 3, we're multiplying by the reciprocal, 1/3. All right, let's take a look at the backside now. So for number 13 and 14, it wants to know what is the 15th term of the geometric sequence. So on our formula sheet, we're going to go to where it says geometric sequence. So we're on this third formula, and we want to find the 15th term for both of them. So let's go up here, and we're just going to write down the correct formula that we're going to be using to start with. And then from here, we're going to plug in 15 for term numbers. Okay, our a to the 1 means what is the first term? So that is 5 times our r, they're multiplying by -3. And then we're going to subtract in the exponent spot, so we have 15 minus the 1. So then we're going to plug that into our calculator. We're going to get a really large number, which makes sure you're not alarmed by this. It is a geometric sequence, so we should expect really large numbers or really small numbers depending on the pattern. Now number 14, we're going to use this same equation. Our 15 again is our ends because we want to know the 15th term again. So our a to the 1 is 3/4 because that is our first term. Our common ratio is, notice how on top we're just multiplying by 1 because it stays the same. On bottom we're multiplying by 2, so our r is 1/2 each time. So we're going to substitute that in, and then 15 minus the 1 is 14. So then we're going to plug that into our calculator. And then when it's like this on the calculator with the e, that means it's in scientific notation. So it's 4.57 times 10 to the -5th power. And what that actually means is I'm moving this decimal back 5 places. So if I start with a decimal here, I move it back 5 places, 1, 2, 3, 4, 5, and I put in zeros as my placeholders, this would be my answer, so 0.00000457. So you can either put it in scientific notation or you can just put it as the decimal. Either would be fine with me. The next one, it says find the missing middle number of the geometric sequence. So in our formula sheet, we're going to geometric mean, which is the square root of x times y. Again, it doesn't matter which one is our x and which one is our y. So we're going to come up here, we're going to take the square root of 171 times our 19. We get 57. Make sure for the geometric sequences we need a plus or minus sign in front of each of them because we don't know if their pattern is multiplying by a positive or if it's multiplying by a negative. We need to know that 4th term. And then for number 16, we're going to do the same thing, 4.2 times our 0.2625. We get 1.05. Alrighty, the next problem, it wants to know, find the sum of the finite arithmetic series. So for this one, we're going under here, under the arithmetic series. If we know the number of terms, we can skip this first equation. If we don't, we need this first equation. And then we're going to use the second equation to find the sum. Okay, so for number 17, I don't know how many total terms there are, so I'm going to use that first equation to figure that out. Okay, so the first equation we don't know the number of terms, so I'm going to leave that blank. My first term is -2, so I can substitute that in. And then I have n minus 1. And then my common difference, I'm adding 5 each time. And then I'm going to plug in my last term here. Okay, and so then I'm going to go through, simplify this down, and get the n by itself. So I'm going to distribute the 5, so I get 5n minus 5. I can go ahead and combine like terms. So I get -7, add the 7 over. So I get 5n equals 30, so n equals 6. So there's 6 total terms. So then I want to go to my sum equation, which is s to the 6 equals 6 divided by 2, and then my a to the 1 plus a to the 6. Now this a to the 1 and a to the 6 just means what is my first term and what is my last term. So then I can simplify that. My first term was -2. My last term was 23. So I'm going to simplify that down now. Let me get the light turned back on in the classroom. So we're going to plug this into our calculator. We get a total of 63. So the sum of those terms, of those 6 terms, is 63. So that would be our final answer. Okay, for number 18, we're going to go through the same process. So we're going to use that first equation to find the number of terms. So our equation, again, let me write it down. Our a to the n, we're going to plug in the last term because we want to know what term number that is. Our first term is 4. Our n, we don't know. And our common difference, we are adding 7 each time. So we put a positive 7. So then we're going to go through and solve for this. So we can subtract the 4 on both sides. So we get 49 equals, and we can distribute the 7. So 7n minus 7. Add the 7 over. So we get 49 plus our 7, which is 56, equals 7n. Divide both sides by 7, and we get n equals 8. So there's 8 total terms. So then we're going to go to the second equation. We're going to plug in 8 for each of our n's. Okay, so then we can reduce this. We get 4, and then we're plugging in the first term and the last term. So 4 and 53. So then we're going to plug that into our calculator. We get 228. So the sum of those 8 terms is 228. Alrighty, the next part is write each arithmetic series in summation notation. So our summation notation is this equation right here. We're also going to need to use this first one to solve for a to the n, so that can go on the right hand side of the summation symbol. So let me get this started. So we have n equals 1 on bottom, and then we have our a to the n equation. Okay, and we're going to just simplify this right hand side so we can solve for our a to the n. So our first term is 21. We don't know the number of terms, and then our common difference is it is subtracting 2 each time. So we can put a -2. And then we are going to just simplify this right-hand side. So distribute that -2. So we get -2n plus 2. Combine like terms, so we get -2n plus 23. So that's going to go on the right-hand side of our summation notation. And then this a to the n, now we're going to plug in the last term so we can figure out what term number the last term is. And then we're going to keep solving for this equation now. So we get 7 minus our 23 is -16 equals -2n. Divide by -2, and we get n equals 8. So that is going to go on top in the n spot. So how can we check our work? If I plug in this bottom number into this term over here, -2 times 1 is -2, plus 23, so negative 2 plus 23 is 21. So it gives me that first term. If I plug in this top number up here, negative 2 times 8 is negative 16. Negative 16 plus 23 is then 7. If I plug any of these terms in the middle, 1 through 8, then I get these middle terms. So this would be my final answer. Okay, so if we try number 20 now, we're just simplifying that right-hand side. So our a to the 1, our first term is 2 plus n minus 1. We don't know the number of terms. And then for this one, we are adding 9 each time. So then we can substitute that in. And then we go ahead and simplify just this right-hand side. So we get 9n minus 7. So the 9n minus 7 is going to go to the right-hand side of the summation symbol. And then we're going to plug in the last term to figure out what term number that is. So we add 7 on each side. So we get 9n equals 146 plus our 7, which is 153. Divide both sides by 9. We get n equals 17. So there's 17 total terms. So we're going to put 17 in the n spot of our notation. Alrighty, for 21, it says find the sum of the finite geometric series. So if we're going to go to our geometric series, it's finite, so we're going to use this sum equation. Don't use this bottom one, that's when we get to infinite ones. And then if we don't know the number of terms, we're going to have to use this first one. So for number 21, we don't know the number of terms, so we're going to use this equation. So I'll write that down. Okay, and then our a to the n, we're going to plug in the last term because we don't know what term number that is. Our first term is negative 3. Our r is multiplying by negative 2, and we don't know the number of terms. Then we're going to divide both sides by negative 3. Make sure you cannot multiply the negative 3 times negative 2. So now we're trying to figure out negative 2 to what power gives me this number right here. So this is going to be a trial and error. Make sure you put the negative 2 inside parentheses. So we need to go higher. Need to go higher. Need to go higher. And we get to the 15th power. So negative 2 to the 15th power again gives us that number. So now our bases are the same, so we can cancel those out, and then we're going to set our exponents equal to one another. And then we get n equals our positive 16. So there's 16 total terms that we want to find the sum of. So now we're going to go to that second equation, and for the n spot, we can plug in our 16. So we're going to have s to the 16 equals. Our first term, again, is negative 3. Our common ratio, we're multiplying by negative 2. And then there's 16 total terms. Okay, now I would not type this into my calculator all in one step. I'm going to just do the parentheses first. So 1 minus my negative 2 to the 16th power. And then I'm going to take that times negative 3. And then I'm going to divide by, these would cancel out to be positive, so 1 plus 2 is 3, so divide by 3. And then that is going to give me my sum. So 65,535 would be my total, which would make sense just because it's going positive, negative, positive, negative. Alrighty, for number 22, we're going to go through the same process. Again, we don't know the number of terms, so we need to figure that out. So we're using this first equation. We need to solve for n. So we're going to plug in the last term here. Our first term is 40. Our r, it's dividing by 2 each time, so our r is going to be a half. You always have to plug in what you're multiplying by. So if the pattern is dividing, you multiply by the reciprocal. So then we're going to take 5 divided by 32, get a decimal, divide that by 40, get a different decimal. So we got to figure out 0.5 to what power equals this decimal. So again, it's going to be trial and error. So then it is 0.5 to the 8th power. So we're going to put 0.5 to the 8th power equals 0.5 to the n minus 1 power. So then we cross out our bases, so we have 8 equals n minus 1, so n equals 9. So there's 9 total terms. And then from here, we want to find the sum of those 9 terms, so we can plug in our 9 in for our n's. And then our first term was 40, our r was a half. So we're going to simplify this down. So 1 minus, I'm going to put instead of a half, 0.5 to the 9th power, and then take that times 40, and then divide it by our denominator, which is 0.5. And we get 79.84 if I round to the hundredths spot. Okay, so for the next problem, it says determine whether the infinite geometric series diverges or converges. If it converges, we need to find the sum. So if it diverges, it's not approaching 0. If it converges, it's approaching 0. So let's go through and tell which ones converge or which ones diverge. So for number 23, notice how the numbers are getting smaller. It's approaching 0, so this one converges. And then this one, the numbers are getting larger. They're not approaching 0, so this one diverges. Alrighty, so for this first one, since it converges, then we can find the sum of it. The second one, since it diverges, we cannot find the sum of it. That would just be our final answer. So let's go back up to 23. We want to use this last formula on our formula sheet because it's infinite. It keeps going, and it converges. It approaches 0. So then for this last problem that we have, it is s equals a to the 1 divided by 1 minus our r. So our a to the 1 is 4, and it's dividing by 2, so if it's dividing by 2, it's multiplying by the reciprocal, a half. So then we're going to simplify that. So we have 4 divided by, and then 1 minus a half is a half, so 4 divided by a half is 8. So then our sum is 8. So we would say it converges, and the sum is 8. Again, on this diverges one, we cannot find the sum of it because it keeps going. It's infinite, and the numbers are going to get larger and larger. We cannot find the sum of that.